Uh, I'm Pedro.
I'm James.
We're both production engineers on Facebook on the newsfeed team. As you can probably see, we changed the name of our talk, the title. Legal didn't approve the previous name. Sadly, it's already published. So. We're going to talk about how we push binaries all the way from the source code to production on the newsfeed team and everything we learned along the way. We're going to give a quick overview of what newsfeed is about. Then we'll talk about the requirements we can identify on the newsfeed system as far as building and pushing are concerned. And finally, we'll talk about how we push this reliably. So let's start with the mission. Newsfeed's mission is to connect the people with the stories that matter to them. The actual mission is actually some 5 paragraphs. I don't know why a mission is so long, but those initial words are good enough to explain what we're trying to achieve there. On the server side, this translates to receive a query, return a ranked list of stories, and that's it. In order to do that, there's a bunch of components around it. Obviously, newsfeed backend is a complex beast. We don't have probably enough time to dive deep on it. And as I said, legal wasn't too fond of it. So we had to do some changes. We had to go back and forth with them. Eventually, I gave up and stopped sending. That's how we got this approved. And we have the kids version. So let's go through it. As you can see, there's a lot less boxes in this. We're going to talk about the components in blue. Those are the ones that interest us. Those are mainly what newsfeed is. Write pipeline, it reads updates. Leaf stores ranking information. And aggregator, it aggregates and ranks and aggregates rank information and produce a ranked list of stories. So how does this work? You and 2 billion other people try to do something on your Facebook app, or one of the apps, iOS, Android, or the web. Doesn't matter. Something like, you post a new image, or whatever you want to do. This is going to be sent to the write pipeline. Write pipeline is going to process this, extract some ranking information, and record on Leaf. Later, you, your friends, someone opens their app, and the app needs new stories. So it's going to query aggregator, and aggregator is going to fan out and query the leaves, gather ranking information, aggregate them, and produce a ranked list of posts. So this obviously has a lot of requirements as far as building and pushing is concerned, so let's talk about some of them. First one is that we like to move fast. Everyone on Facebook wants to move fast, so not unblock someone else. So how will you move fast with architectural requirements? Obviously, the architecture is a lot more complex than this, but this serves the purpose of illustrating some of the requirements around architecture. For example, on the write pipeline, as you can see on the diagram, we're sending through 2 pipelines. So when you're pushing a new version, you're not supposed to roll both pipelines at the same time, trying to avoid problems. On the Leaf side, as you can see on this very elaborate diagram, it's a sharded DB. It's a sharded database, as you can see. And being a sharded service, you're not supposed, when pushing a new version, not supposed to put all copies of a single shard down at the same time. So you have a requirement on that too. And on aggregator is simpler. It's stateless. But then again, it's ranking for a lot of people. So it's a very compute-heavy service. You cannot push using any step size you want, push a new version and it's using any step size you want. You need to control your push speed depending on your utilization. So another requirement is around people. Newsfeed team is constantly growing. It's a big team. And Facebook engineering culture is around encouraging other teams, everyone in the company, to collaborate on the code if they find something that's necessary to change. Sadly, not everyone likes to test their code. And even when you have forced tests, some of them are very nice and skip their tests. So another requirement is we need some tooling that help us to easy catch those errors when those people introduce them. We don't like them, not at all. Another thing is that every single engineer is going to reach to you and say, hey, I need this code to reach production now. I never saw engineers saying, wait, this is not important, let's wait forever. This doesn't need to be rolled. They need to roll it now. And on newsfeed, it's true most of the time. For example, they need to test something before a major launch. Or the new feature they're introducing is actually supposed to be used on a special event, like Christmas or, for example, Super Bowl. Or like on the previous talk, like Eben said, sometimes someone introduced a print line somewhere, and now when you have a print line being shown in the log, but you have 2 billion people accessing your system, guess what happens? Your log storage service, someone on your log storage service is going to come to you, hey, you killed us. Can you please fix this as soon as possible? So we need to push often. That's another requirement. We need to push as often as possible. We also have requirements around our binaries. It's a very different thing on the newsfeed. We need to build often. It's not actually just wishful thinking. It's not a matter of getting fast to production. It's not just a matter of pleasing people. If with the amount of changes being introduced on the system all the time, I told you that people from other teams also introduce changes on our system. So if we don't build often, what is going to happen is that between versions, we are going to have thousands of changes. And I can guarantee you, you cannot bisect a problem quickly if you have thousands and thousands of changes. If you do, please send a resume. We probably want to hire. And yeah, we don't use PHP on the back end. Everyone knows that Facebook uses PHP for a lot of things, not on the back end. On the back end, it's composed of a bunch of C++ binaries. And the problem with big C++ binaries is that it takes a while to compile. And a while, it can mean hours. It can be even worse when you're doing link time optimization. Link time optimization, it's very useful for saving on costs, but it also takes even longer than compiling. And to top it all off, we also build multiple flavors of a binary. Some binaries, they have assertions, more assertions. Some have instrumentation added to them. Others, they are built using different compilers just for comparison. So we need to build all those things really fast. The last kind of requirement we learned from the team's past. This is not a push system. This is a janky bash script. It is also not like what we had in the past. Ours had traps and send emails when it failed. It was very engineered. So we had a mishmash collection of bash scripts in the past. Bash scripts, PHP scripts, cron jobs running everywhere, random alerts. It's not actually that useful. Nothing was really tested. Someone ran, oh, it broke. That's the testing that happened. And it ran, who knows where. It ran on someone dev's box, and you don't know whose dev box is running on. Detecting a problem usually means, oh, I have nothing to push today. What is going on? Probably too late to realize that. And I know we love our shell one-liners and all that, but you cannot actually build a system in bash. I'm not sure if you tried doing unit tests or integration tests on bash. Not the best thing in the world. So another requirement is that we have, and that's another thing. Not everyone on your team might know bash that well. You need to pick something that everyone on your team knows and can write tests for. So another requirement is having a proper build and test system. So how can we achieve this? I'll let James talk about it. I just want to talk about the bad stuff.
Cool. All right, I'm James. Yeah, so achieving reliable pushes of C++ services, it's interesting to say the least. I'm going to kind of high-level this. We'll kind of walk through a pipeline together, and we'll see like some of the lessons we've learned and how we actually maintain this on a daily basis. It's a lot of work, actually. Cool. So we need to answer the first question. What is a reliable push? So each section of the push phase has an SLA associated with it, most importantly. There is padding time around these phases, but ultimately, one phase can hold up the entire pipeline, and then an engineer has to get involved, and I don't like doing any more work than I have to, so that's never good. And then most importantly, this is where everything is based off of right here, is having trustworthy testing phases. If the tests are low signal or constantly flaky, the whole push phase is meaningless. And then when these tests don't catch something because they're not trustworthy, you end up pushing on bad binaries into production that are not working or are degraded for whatever reason. And then when this does happen, how do you detect these? And you need to have high signal monitoring. Having people babysit your push, it's not sustainable, it's very error prone, and it will blow up in your face almost immediately. And then second, like I said, I don't like doing anything more than I have to, so having engineers stay out of the process is pretty important, and the frequency at which we push is not sustainable to have people involved all the time. So let's start with a little overview of our pipeline here. Well, in an ideal world, engineers are going to commit working code, something that runs, something that builds. Ideal world. Then the scheduler will basically take the source tree and build a binary package from it. As Pedro kind of hinted, this happened, well, there will be multiple binaries built from this, but let's leave it at one binary for the sake of this pipeline. Now we've actually got to get some builds going. Well, this begins with a compiler. One of the big things that we do to stop bad code from even being checked in is build them ahead of time on a per commit basis. So engineers will put up a diff, and it gets built, and if it builds, we'll usually let it go into the source tree for production. If it doesn't, well, tough luck. And again, we build a lot of packages throughout the day. I cannot emphasize this enough. This is super important. Having enough builds basically makes bisection effortless. In turn, getting the push process back online. And then my most hated moment is dealing with compiler faults that happen between different compilers. LLVM may be crashing, GCC may be happy, and it becomes a nightmare. So pick a compiler and work with it, because then when you're building these on a per commit basis, it basically, when you get to this point, you already know that it's going to build. And then kind of following this up is keep a consistent runtime and compilation environment. If you're building and linking against libraries that are not actually what is running in production, you are going to shoot yourself in the foot at some point. It is not going to be predictable behavior, and you basically invalidate all of your test phases at this point. So do simple things like statically linking. Yes, it may be a little bit more expensive to distribute the binary, but it does save you a lot of effort. And then finally, really retain the debugging information. I know everyone in this room writes perfect code. I know it. But ultimately, the binary is going to crash at some point, whether it's due to bad hardware or some other issue that is arising. You're going to need to be able to investigate it, and having the debugging information either embedded in the binary or on standby really saves you a lot of effort here. All right, we're getting there, I promise. Now we can get to the most important phase, which is testing things. So this is definitely the most fragile part. It's the part that costs the most engineering time to implement properly, and it causes the most involvement from engineering to just keep it up to date. So the first thing that you can really do to help keep things tested and keeping bad diffs out of the pipeline is unit and integration tests. Yes, it's obvious, but these are fast, cheap, and they're usually quite effective. And you can do this, again, on a per commit basis when you're building things. So you stop something bad from even making it into the pipeline to begin with. And at some point, we're going to need to get traffic to the binary to see how it's actually going to react in production. So at this point, we're not confident enough in the binary that it's going to return real-world results in the way that we want them to. So we shadow requests to the binary. At first, we do this without a lot of load, something that we can just see results and actually analyze issues if there are issues. And then we follow this up with really high load scenarios where we duplicate these requests even more and basically try to pinpoint regressions in performance or even like oddball crashes. And finally, with respect to the testing phase before we get into production is we introduce some chaos. So making sure that if the binary depends on something and that dependency goes down, either if that's a local service or some remote service, we know that it's going to react predictably. We may not catch every edge case with this, but it's to make sure that the binary has the determinability to it. And now we've got enough confidence that we can introduce a little bit of traffic to it from production. We know that it's not going to completely blow up, maybe. And if it does, it's a small amount of traffic at this point. So if it does blow up, it's usually self-contained, and it's really not a big deal. And this really is an important phase because if our binaries are, like as Pedro said, our binaries are super complex. So if these business level metrics, a lot of ranking models and stuff of that nature change in a bad way, we know something is up, but we don't necessarily know what. Well, we can stop the push at that point, even before it has started, to get business level metrics corrected. And then finally, track the success of these pushes and their test results. If there's like this constant flakiness that happens, intermittently throughout the week, something is up, and you really need to account for this in some sort of edge casing in your testing frameworks. All right, we made it. Let's push the most recent tested package to production. All right. This should never be a scary moment for you. If it is, you're probably doing it wrong. And there are a few things to get right, though. So you really need to push at the right time and at the right rate. If you're pushing during the peak for your service, you're probably going to end up in a bad situation because your service is going to start running really hot. And even if you're pushing too much at one time, your service is going to run really hot. So and you also need to factor in other offices. Are your pushes potentially risky? Do you need to factor in people in remote offices to help coordinate things? So this brings us to progressive rollouts. We need to start at some phase. Usually this is a percentage or maybe some geographic location where things start to move from. So we can start to monitor issues. Yes, we've done a lot of testing at this point, but it doesn't mean something still can't blow up as it starts rolling to production. So progressively roll this out, give it a time to bake. Next, even when the service is pushing, I've kind of hinted at this before, but make sure the service is monitored to 100%. Actually, 110%. You really need to be able to stop these pushes if they're going wrong. Again, this is really kind of obvious, but you wouldn't believe how many services that you can run across that don't have proper monitoring, that haven't had a proper analyzation to understand what metrics actually matter to the service. So make sure that's set up, and make sure that your engineers can do more exciting things besides watch your pushes. Let them have trust in the monitoring. And the moment that you realize your push is bad, I mean, that's always heart-sinking, especially when it's a Friday night and you've had too much beer. And so be ready to revert. It should not be complicated. It should be the big red button that you can mash, and it just happens. Do not wait till the last minute to test this stuff. A lot of stuff you can wait to maybe test it in a real-world scenario. Not this. And ultimately, someone is going to need to get their hot fix in on Friday at 10 p.m. And you need to be able to do that quickly. So have tooling around this to do releases ad hoc very quickly. You shouldn't have to think about this. You shouldn't even have to get involved. It should be what patch do you need and how can I get it in there quickly? Cool. All right. I think I've said it enough at this point, but automation. All right. So the automation is going to fail at some point. It's just going to happen. It's what keeps us employed, which is awesome. And you really need to have someone ready to answer these. Sometimes this can come in the form of an on-call. Usually bigger services have to have a dedicated on-call for this. The push takes a lot of maintenance. It takes a lot to keep it up to date, especially with the speed that things move at Facebook. So yeah, having an on-call to keep this going is pretty crucial sometimes. Second, really give people a reason to care about the push. If people don't care and they just want to get their diff out, it doesn't matter. It's going to constantly blow up all the time. So give them a reason to care. If they know that their stuff is going to be pushed on time, well, awesome. And if the on-caller knows that, oh, hey, if I take care of this issue now, I'm not going to have to deal with it in 2 weeks, or I don't have to dump everything on a pager over here, which it usually is the other way around, though.
I like bad stuff.
And to help this out is assign SLAs to push-related issues. That way you know that they're getting fixed, you can track them, and it helps set the precedence to keep things going with good hygiene for the push. And again, keep monitoring high signal. If you're getting chirped at 3 in the morning for a push, something is seriously wrong. And so, again, getting back to this is really make sure this is ironed out. If it becomes flaky, fix it immediately. And finally, productionize everything. Pedro kind of outlined the script for this. If you have a script like that is running on your dev box, I don't know what to say at this point. So yeah, keep it productionized. There are people on this stage that are guilty of this, and it is not the person talking. So
I like my script.
Anyways, so that's kind of a high-level overview of everything. Here are some takeaways from everything. Reliable high-frequency pushes, yes, they sound intimidating. Yes, it sounds intimidating when you have a ton of traffic, but they are attainable. It takes a lot of maintenance, but they are attainable. Build and test more frequently. Do this as much as you can. As much resources you have that permit this happening, do it more. Even if you're retesting things, you can help reduce flakiness. And again, flakiness and lack of care really set a bad precedence for the team and even the organization sometimes. So if you're the only person that cares, keep pushing. It will work out at some point. You'll find the people that care with you, and you'll prevail eventually. Babysitting things, well, I can barely take care of myself, so I don't know how I'm going to take care of the push. So automate everything, and be ready for the failure. It's going to happen. You should have well-tested operations in place to revert and triage things. And then finally, value the engineers. You should not have your engineers doing things that don't matter. Especially in the Bay Area, they are very expensive. So let the computers handle the repetition. And thanks.